Hi. So this one here is actually a more theoretical example that we see a lot in books about domain testing, and I'm gonna show you why this example is so common. So let's suppose you have the input domain of a function. This function has an x and an y, and this x and y, they have to meet this following criteria. So x has to be greater than 1 and smaller or equals to 10. Y has to be greater or equals to 1 and smaller than or equals to 10, and y has to be smaller than or equals to 14 minus x. So you see this relation between y and x, right? So x kind of restricts what y can be about. So if we look at the variables, so both are integers, they do have their specific restrictions. Let me even change these things in place so that this restriction is only about y, but y also has this addition here. Yeah. So x and y, they have this dependency relationship, or more specifically, y depends on x. Let's go for the analysis. And how would I do this analysis? So first, x alone, right? We have one restriction that is only about x. This one here, 1 smaller than x is smaller than or equals to 10. And I have, well, two numbers there, two boundaries, one for each side. So I can get 1, which is the on point, and then 2, that is the off point, and then 10, that is the on point, and then 11, that is the off point. But I can never choose x alone, right? Y always follows. And for y, because in this test I want to focus on x, right, on bugs that can emerge for, or on this class in particular, I'm going to just pick in points for y. Yeah. So in points meaning y is always inside of the domain. But of course, when choosing this, I cannot simply pick any y, because I have this restriction, right, 14 minus x, that I have to respect. So when choosing the y, I really have to think about which y to choose. And for example, maybe in this case here in 1 it's easier because the restriction doesn't really get big. But for example, if you think about this, when x is 10, you have way less y's to choose because y has to be smaller than or equals to 4, right? 14 minus 10, 4. So the bigger the x, the more restricted y is. So that's what I want to call your attention to. Then when we go to y, we have a similar restriction. So we can just pick values for y based on the on and off analysis we saw how to do it, that we know how to do it. And then we choose in points for x, also respecting the restrictions of x. So x has to be between 1 and 10. Great. And then we go and analyze the specific restriction y smaller than or equals to 14 minus x. And so this is a bit tricky because we have to kind of try to understand how this function works. And without really relying on any mathematics for now, what I will try to do is to push y to the max that it's possible together with the max x. So how can I push these two numbers to their max? Because I feel like there's a boundary there, and that's what I'm gonna do. Then if you try numbers, you're gonna see that the maximum you can push both variables together is for this x4 and y10. Yeah, so having y as a priority, what is the maximum y that I can have together with the max x that I can have? So that is one boundary, and then I could try to explore this boundary, right? And I chose just one, for example, 510. So I just explored a little bit out of this this input over here, and then I did the other way around. So what is the maximum x that I can have with the maximum y? Let me even complement here. And then the off point. Yeah. So this is one way to do this, by actually looking to each one of the restrictions separately, yeah, and try to explore the restriction as much as you can. And then, well, I derived tests for the 12 boundaries that we have in here. So 12 tests directly. But you know, analyzing this function is a bit tricky. And this example is quite famous because you can actually try to plot it. So look at the picture I have there now. What I did was I basically plotted all the points that are possible, and they are in blue. Some of them are blue and red, and you cannot really see it. Let me see if I can actually turn this off very quickly. So let's suppose I just delete it. Yeah, better. So this is the entire input domain. So these are all the possible values for x and y. And if you look at this picture, you can easily see boundaries, right? Because we have 1, 2, 3, 4, 5. So we have like kind of 5 points in this picture there, in this form there that we see. And maybe what we want to do is to exercise these 5 boundaries that we see, right? So why not? And that's what I then try to do by only looking at the picture, and then I just try to create a test to each one of those points that I see in the boundary, and then a little bit off. Yeah. So that could be another strategy for you to test, and this is what you see in a lot of books. People trying to plot this, for example, in graphs, in plots, in charts like this, or even using some constraint programming. So you give these to a constraint solver, and the constraint solver solves the constraints for you so that you can derive some tests. Yeah, so this is a bit tricky, a little bit theoretical as well, but I just wanted to show that maybe you can try to visualize how the domain behaves, right? And then if you visualize how the domain behaves, you can pick the points based on what you see. Yeah.